definition. We say a function f is what? Even if f of minus x equals f of x. This is what we mean by an even function. This is really right here, the criteria right here. So if you said, have I ever seen that before? You've seen that today. What does that even mean? Right? If you change the what? The input, and you make it negative, and that's the same as if the input was positive. Have you ever seen that today? Yeah, which one did you see? Which function has this behavior? Yes, cosine of minus theta is what? That's what we mean. What does it mean about cosine then? Cosine is what? Cosine's even, ladies and gentlemen. So if the input is negative there, and it doesn't change your answer for the output like we're looking at that, then we say the function is what? Even, and that's the example that we have. Cosine is a nice even function because that negative angle doesn't change the value of cosine. So we've been working with some even, I should say functions, an even trig function. And then definition, we say a function f is what? Odd. If f of minus x is minus f of what? X. This is the definition now of what we call a what? An odd function. So, maybe we'll put pink. Pretty in pink. So this is the criteria for being odd down here. Now, have we seen odd functions today? Say yes. How many odd functions have we seen today? Let me give you guys a hint. See if you guys remember this. What do we know about sine of a negative angle? That's minus sine of the what? Positive angle. Is that true? What do you guys know about tangent of a negative angle? That's what? Minus tangent of an angle. Did you pull out the negative signs? Say yes. What do you guys know about both sine and tangent? Those functions are what? Odd functions. Good. It satisfies the definition of being what now? Odd. So you might say, are there any other kinds of functions that are even and odd? Well, let's take a look. Anybody here taking Math 260 by any chance? Okay. Let your function f be x squared. We'll start with something very simple. I'm going to ask you guys, let's double check here. Is this function even or odd? Okay, what do you guys do? Do you guys know what you want to focus on? Here's the process. Okay? You see the function f, you replace that with a what? See this input right in here? Let's get a highlighter. Maybe orange? I don't know. See that input there? See that x? That's the same x as that you see on the right side. So change that x to a what? To a minus x. Okay? Can you guys see what I just did? If I highlight it, just change your x to a what? Minus x. Easy peasy lemon squeezy? Okay, now focus on this side here. What do you guys know in terms of algebra on the right side? What is this? Isn't that negative x times negative x? Is that true? What's negative x times negative x? Positive x to the what? To the second power. You guys okay with that? Is that true? All right, now I'm going to say something here to you guys. Have you ever seen x squared before? What does that look like? That's the original what? Function. Isn't that true? So we replace the x squared with what we know it's really called. It is called f of x. So let's see if you guys can see my point here, at least in terms of the highlight colors. What you have shown is that the left-hand side, ladies and gentlemen, this is what you have shown here. F of minus x is the same as f of x. Is that right? What does that mean about your original function? It's an even function. So this one is nice and what? Even. And I want to remark, notice this here about the power too. Isn't that power even? So this is kind of a demonstration to you that the x squared is a nice even function here. This is what we call a proof in some ways. I just proved to you guys that the function x squared is even. Okay, you want to see an example of an odd function? And I can prove it to you as well? All right, let's give you guys another function. This is an example of a nice odd function. F of minus x, f of x, sorry. We have to give you the definition. What function do they want us to look at? X cubed, okay? The x cubed function, believe it or not, it's going to be a nice odd function. What do I do in the process to show that it is odd? You see this input? What do we do? How do we start the process? Always replace it with a what? Good. Put the negative x instead wherever there's an x. Okay? So let's see if you guys can see what I did. See here? Here. You guys okay with that? Replace that x with a negative x. Now, raise this to what power? The third power here. What do you guys know about doing a little bit of algebra here? What's negative times a negative times a negative? Negative. And that's repeat multiplication, right? So that's x to what? The third power? Right? X to the third power? You guys okay with that? Now, what does that even mean? I'm going to focus on this. There's a negative here, and I'm going to paint this green now. Why am I going to paint that whole thing green? Have you ever seen x cubed defined? Yes, x cubed is really what? That's your f. Is that true? So we get to replace that x cubed there with f. But don't forget there's a negative sign in front. So you got that negative sign. Here's my f. And in conclusion, what do you guys know? You just demonstrated that f of minus x is the same as minus f of x. What does that mean about your function? This is an odd function. So, ladies and gentlemen, we have shown you the definition of what an even and odd function is. And really, you got trig functions that could be even and odd as well. And that's kind of where it comes from, so you guys know. So we just started taking a look at this idea about even and odd functions. You're going to see why you care about them in the future. But ladies and gentlemen, this is kind of a demonstration on where it comes from. An odd function. Sine is odd. Tangent is odd. What else? Cosine is nice and what? Even. Should we show you another example? Or should we wait till tomorrow? Let's wait till what? Tomorrow. Now, if you came in, and I also want to say what I let students use on their exams, if I go here, is the trig cheat sheet I created. And I think, well, this is one sheet. As you guys know, you've been working with this unit circle. Is that right? So you guys are going to, I will print this for you. I print it for you. Good morning. You don't have to print it. I print it for you. So it has some fundamental information that you may find useful. Some definitions there too. So anyway, that's what you'll be able to use as well. So I just want to do some administrative chores for you guys this morning. And where did we leave off? I do know we left off here with what? Even and odd functions. Is that true? Okay, so I'm going to give you guys a quick little warm-up here and reminder to you that in using the definition we used yesterday, we know cosine is an even function. Is that right? We replace the input there. Well, cosine minus theta is the same as cosine theta. That's the definition of an even function. We also have the definition of an odd function. That sine of minus theta is minus sine theta. And that's the definition of an odd function. And then fundamentally speaking, we go back to a little bit of algebra. We say x squared is even. We prove that here. This here is the process you want to focus on. This here, this is the process we'll focus on this morning. And then over here, this is showing that x cubed is an odd function. So again, this is the process as well. See if I can make this bigger. So, ladies and gentlemen, here's the deal. I'm going to have you guys warm up with that process. I'm going to say this. Show that the function f given, function, is either even, odd, or neither. You might say, what would neither be? Well, you'll see what a neither would be. Now say, here's x squared sine x. Okay, and then maybe give you like an x to the fourth power cosine x. How about tangent x over x? And then maybe we'll try here sine x plus cosine x. Okay, we'll do a quick and easy questions here for us to go over the process we did yesterday. You're going to use those definitions. You might say, what was the process? Right? You always start the process, like for the first one. If I said to you, your function for the first one, f of x is what? X squared sine x. What you always do as a starting point is to replace what? You guys remember? I can't remember the colors we even used. Yeah. You see that X? Wherever there's an X, what do you replace it with? A negative X. Good job. So you replace that X with a negative X. So what you'll see is f of negative X, right, is what? Negative X squared. Sorry. This is what you'll see. Do you guys remember that? Now, just to kind of maybe finish this one off for you guys here, just to kind of say, okay, so algebraically speaking, you want to know what happens where? Right in here. Is that true? What's negative X squared? Anybody know? What did you see from yesterday? That's just X squared. Is that right? Okay. And what sign of negative X? So that will be negative what? Sine X. Is that right? Now, what's a positive times a negative? You say, is there a negative? There's a negative here because this really means negative what? 1 times. Is that right? So what can I do with that negative sign? We pull it out. Now you have negative X squared sine X. Okay, so what do you think this means? Does anybody know? Well, you're going to use that negative sign, and I want you guys to really see something here. I'm going to get out my highlighter, right? What is that green function known as? Right? That green function is right here. Isn't that called f? So what that means here is that this is minus what? F of x. What did you guys just show? You showed f of negative x is what? F of minus x. So what I sometimes write down is that statement. F of negative x is going to be what? Minus f of x. What does that mean about f? We say f is going to be what now? F is an odd function. Good job. And there it is. You're done. So that was the process, ladies and gentlemen, we started yesterday. So what I want to see now, I'm going to add a number 5 here for you guys. Maybe bring it all up. To warm up here, get nice and warm. Well, since I did that one for you guys, I don't want to take all the fun. How about if we put sine x times what? Cosine x now for number 5 here. So I'm going to give you guys some time to do the same process. You want to replace your x with a negative x and see if the function's even or odd, and you could have neither. It may not be either. All right, you guys have that process in your notes? This is the definition down here of being an odd function. So try this out with these functions this morning. We'll give you guys some time. Let's get out the timer. Come on, timer, where are you? And let's see what you guys can do with that. Okay, ladies and gentlemen, let's try to go over these here. We're going to try number 2 now. Okay, now remember the process always starts by doing what? Replace that x with what? A negative x, okay? So you now start here. You say f a negative x now is going to be negative x to the 4th power cosine minus x. Is that true? So notice my point to you. That negative x is your input now. So what does this even mean now? F a negative x, what does this first part become? It's x to the what? To the even power, yes, x to the 4th. And then what about this part here, cosine minus x? What's that going to be? That's just going to be cosine x. Is that true? All right, now, what do you guys want to notice? Have you ever seen this portion here somewhere before? Say yes, you see it here. It's defined to be just what? It's defined to be f. So the right side equals f, while the left-hand side is f of minus x. What is that the definition of? We say f here is what? We have an even function. So, ladies and gentlemen, you're going to have to show this. You have to demonstrate this. This is that process. Does that look like what we've been doing here? Right? You guys okay with that? All right, let's see number 3 now. Yep. So right over here, right, you're going to look at this input here. X, tangent, and x. Say f of minus x is going to be what? Tangent minus x over what? Negative x. Is that right? Okay, so we're going to have to really think about what happens over here now, right? So what do we know about tangent here? What's tangent minus x? Negative tangent x. Good. And then you have this over what? Negative x. Now remember what that negative sign means. This is negative 1 times, negative 1 times. So what's this negative over a negative? Isn't that positive, or it's gone? It cancels? Okay. You guys see the point? So what does that mean right up in here? Anybody know? Have you ever seen that before? That's the definition of the what? Function f. So on the right side we have f. On the left side is f minus x. This is the definition of f is what? Even again. There it is. So here is the process they want you to go through. Okay, number 4 now. Let's see. Okay, what do you replace your x with? Negative x, negative x. Okay. So now you have what? F of negative x is sine negative x plus cosine negative x. Is that true? Okay, what do you guys know now? You say, what do I have to do? We have to know what sine of negative x is, and we have to know what cosine negative x is. So what's sine of negative x? Negative sine x. What's cosine of negative x? Cosine x. Good. Now, let's ask you guys this question here. We know f is defined to be what? Sine plus cosine. Is that true? What do you guys have down here? Is that f? Is that equal to sine plus cosine? Right? Does that equal f? What would you guys say? No. It's not. How do you know it's not? There's a negative sign, so it doesn't equal f. Okay, okay, good. Then does it equal minus f? What do you guys think? It doesn't equal f, but does it equal minus f? The answer also is no. Why is it a no? Yeah, because f is going to be sine plus cosine, right? So what I want you guys to note here, that minus f would be negative 1 times that f, which is sine plus cosine. Minus sine minus cosine. So there's two negative signs. So then you say, I don't have that either. So then what does that mean? This is the what? Neither situation. So the function is neither even nor what? Odd, because you don't have it equal to f and it's not equal to minus f, and that's the situation for number 4. Easy peasy lemon squeezy. What about number 5 here? Say, oh, times. Okay, same exact process. So you say, replace this x with a what? Negative x. What's sine of minus x? Negative sine x. So we have to use the property here for sine, right? Because sine is odd. What about cosine? Cosine is what? Even. So that's just cosine x. Is that right? So what does this mean? Do you guys know? You got negative here. And sine times cosine. Oh, that's what? That's your function. So you have negative f of x. So on the left, you have f of negative x. On the right, negative f of x. What does that actually mean? Do you guys know? Yes, your function f is what? Is an odd function. Good. Good job. All right. Now, ladies and gentlemen, let's give you guys another example. What if they said, hey, your function is cotangent? Could it be cotangent? Sure. Replace your what again? Oh, do we have our audio, I hope? Yes, we have our audio. Good. You guys have students panicking and crying at home in their pajamas. Is that right? Okay, so you got f of what now? Negative x is cotangent of what? Negative x. Do you guys happen to remember anything about cotangent? Is cotangent? Remember, tangent is what? Yeah, it's reciprocal, but is tangent even or odd? Odd. So what do you think is going to happen with cotangent? It's also odd because they're reciprocals. So that would be minus what? F of x. And that means your f function is going to be what? Is that odd or even? That's the definition of being odd, right? There it is. Now, remember, on your test, they're going to ask you to show this. You don't just guess, even, odd, even, odd. No. There's no what allowed here. No guessing, only skill. No guessing, only skill. Let's give you guys a hard one. You guys want to see a hard one? What if they give you x secant x? That one's going to be a hard one. Is that right? So what do you replace your x with? Negative x. Let's go through the process. So f of what? Negative x will be negative x secant of what? Negative x. Now, secant is a reciprocal of what? Cosine. Is that true? So what do you guys know about cosine? It's even. So is secant. So like before, you may notice, hey, here's my f, isn't it? So you have minus that f. So we got f of negative x is minus f of x. F again here is what? Is odd. Okay, you guys okay with that one? Easy peasy? Yeah, question? Question, yeah, somebody has a question? Yes, I'm sorry.
Yeah, secant is like the same rule for cosine, right? Where it always stays
Yeah.
positive? Okay.
Yeah, secant is because it's the reciprocal. Yes. So I want you guys to see that here. Replace the x with minus x. Okay, now cosecant is a reciprocal of what? Sine. What do you guys know about sine? Is sine even or odd? Huh? Odd. So you're going to put minus what here? Minus cosecant. And then what about the algebra down here? Minus x squared. What does that give you? X squared. So this negative 1 sign here gets pulled out. And what is this? Have you seen that before? That's what? That's f. So we have here, ladies and gentlemen, minus f. And this will be f of minus x. What does that mean about your function f? F is what? Odd. Ladies and gentlemen, there you go. F is odd. Yeah, so, just to kind of remind people here, just to give you guys as a note, and we said, well, cotangent, you know, minus x, I know that's 1 over what? Tangent of minus x, right? Which would be 1 over minus tangent of x. Here's my point to you guys. And I could put that back in as a cotangent. So this is why a cotangent is an odd function. So, I mean, we could do that with secant and cosecant as well, but that's what I want to notate for you guys here. So if you know the reciprocal is even or odd, it translates to the, let me say that again. If you know sine, cosine, and tangent are even or odd, it translates to the reciprocals too, is what I'm saying. It translates to those reciprocals. You go, I don't think so. Well, okay, well, what's secant? Right? If you say secant minus x, it's 1 over what? Cosine minus x. We know cosine is even, so we say cosine x, which is also known as secant x. So again, it translates, is my point here. This is an even function. So, just as a note to people, minus cosecant is 1 over sine, and it translates, and we say, okay, that's minus sine x, because sine is odd. Well, then that will be, again, minus 1 over cosecant x. So, again, cosecant is odd just because sine is odd. So all of those ideas are at play here. And I don't know if you guys know about the absolute value function. Do you guys know about the absolute value function? Do you guys know about that function in algebra? You've ever seen that? Is the absolute value function even or odd? Well, let's see, right? Let's go through the process. F of minus x is the absolute value of minus x. What does that absolute value do to every function? I could give you some details in algebra. Negative 1 times x. Can I bore you with some details here? Negative, so that's what? Negative 1, and then the product rule for absolute value. And we know the absolute value of 1 is just what? 1, so this is the absolute value of x, just to let you guys know. So there's a little bit of algebra there for it, which is the same as your function. So the point I'm making is, you are correct. The absolute value function we called f is a nice even what? Function. And there's the real demonstration. So I just want to get you to do a little bit of algebra, remind you guys that you have the product rule for absolute value, which was what we use. And there it is. So if they said, what's the absolute value of x? Oh, cosine x. Okay, is that even or odd? What would you guys do? Same thing. Replace the x with a what? Negative x. So we know the absolute value of negative x is the absolute value of x. What's cosine of negative x? Cosine x. In other words, like before, you have to know what this is, and you have to know what this is. Is that right? And at the end, have you ever seen this function before? Yep. What do we call it? That's f. So the left side says f of minus x is f of x. That means f is what? Even. So what if they gave you a function like this, just to compare and contrast? Right? What if they change that cosine function to sine? Right? How does this process change again? Well, it doesn't. Wherever there's an x, you replace it with a what? Negative x. So you're going to get f of negative x becomes absolute value of negative x sine of what? Negative x. What's the absolute value of negative x? Well, it's the absolute value of x. What's sine of negative x? Negative sine x, right? So what do you do with this negative sign? Do you guys know? What do you do with that? Because that's really negative 1 what? Times, right? So the order in which you multiply doesn't matter. So I can put it on the outside here. That's why I can move that sign on the outside. So that negative sign here, which is really negative 1 times, is on the outside now, and then I recognize that this is really my function what? My function f. So this will be what? Yep. And remember, it's not that you guess, it's that you what? Show. This is the show, ladies and gentlemen. And that's the process behind the even and odd. What do you guys think? It's not so bad? May not be. Well, if f of minus x is minus f of x, you're using the definition of being odd. This is the definition. So that's what you're showing. F of minus x is minus f of x. The function's odd. So, ladies and gentlemen, there you go. And there it is. So, also kind of remark here about something. If we go back to the unit circle here, remember